Hello, hello, and welcome to another Python programming video. It's great to see you, and in this video we will do a project called edge detection. So before we move on to the project, I would like to thank you all for subscribing, and I'm so excited to make this kind of programming videos and simple tutorials. And yeah, let's get back to the project that we will be working today. Let's begin by sharing the screen. Here we go. So this is the way I follow in my videos. I share the article that got published on Towards Data Science publication on the left hand side, and on the right I have my text editor. So here we are writing the program, and here we are following the instructions. So this is an article that I wrote, and it's published on Medium, which is a blogging platform. I will share the link in the descriptions if you want to check the article. And yeah, that's all. So let's start. So what we will be doing today is called edge detection. What does that mean? That means if we ask our machine to define the objects in the image. So this will be a beginner level project or tutorial that we can also call. So as you can see, this is like a result what we will be doing. This will be our image that we ask the machine to find the edges, and this is the result that we are receiving from the machine. So let's move on without losing any time. You can check the article if you want to read more about these. I will come to the point, and here we go. So we will install these libraries. Since I already have them, I don't have to install them, but you can go ahead and open your terminal window and just type pip install and numpy, matplotlib, and opencv python. You can just type them all in one line, and then the installation will begin. When you are done with the installation, it's time to move to the programming. And what we will do by starting to import the libraries that we just installed. It's really simple. All you have to do is just copy that and paste it in your program. That's it for importing. And then second step is writing the edge detection function. So this is where the things gonna happen, and you can rename your function. You can just type something else, it's your choice. You can just copy that and paste it in your text editor. As you can see over here, we have the function name, we have the image as an attribute. If you want to pass something inside the function, that's how we do it. We just type the variable name in between those parentheses that we want to use in our function. So this is how we do it. You just put the variable name between those parentheses. And then let's get inside the function. So what we are doing over here is we are using a edge detection model which comes with the OpenCV library. So that's the model that we are using to find the edges in an image. So all you have to do is just this line of code, and if you're wondering what is 100 and 200, those are the maximum thresholding values. You can search more about Canny if you want to learn more. Alright, so this will get the image that we want to pass inside the function, and then it's going to find the edges, and then it's going to assign it to a new variable, which is, in my case, it's the edges detected. Let's move to the next line. What's happening over here? As you can see, we are creating an array with two image files. One of them is the image that we passed inside the function, which means the image that we didn't do anything on. Like it's the default image that we passed in. For example, the original image in this case. And the second image is the image that we found after running the method, the edge detection method. So we need this part to create a chart or a plot and compare those two images. That's what we are doing in these following steps. As we installed earlier, we are using the matplotlib library to do these plots. Okay, when we are done with the for loop, which we were putting the images side by side, so it's just two items, as you can see, the first image and the second image. Alright, what's happening over here? We are saving the plot, and you can also rename this however you want, and then after saving the plot into our folder, into the file, sorry, not the file, the folder that we are working in my case it's this folder. So here you can see the other images that I tested the program, and which we will come to them in a second. So after saving the result, the final result, we are showing the plot. So this will open up a new window with the results. It's just a new window showing the results, so nothing complicated. And the last thing we want to do in this function is to save the image, which in this case is the edges detected. Alright, so let's move on. And what we are doing over here is we are passing an image. So to go to this step, first we have to find an image. So here is an example that I showed on the article. So I also shared the link to a website where you can download images, like high quality images that you can choose and download and use it in your program. So let's go back to the folder. So here you can see I have a couple images. You can see their names. You can see how they look. So in our program, let's work on this image. So it's called test image 2. So I'm gonna pass that image to my function later on over here. So first we are passing the image and assigning it to image variable. And then we are running the function. So this is the final step. And then we are passing this image inside the function and just leave the function over there. So this will trigger the program. After we run the program, this will trigger the function to run. That's how you can call functions. All right, after all these steps, let's see how it works. Here are some results that I shared. Okay, so I'm going to the terminal window, and then I will run the program. Recognizer, this is the file name that we just created, and then this is how we run the Python program. Let's click enter, and then there you go. Here we can see the plot window that I mentioned earlier. Over here, where was it? Yeah, plot show. So this triggers the program to open up a new window, and you can see the two comparison images side by side, before and after. So however you want to call them. So this is what our machine sees, like, as you can see. About the self-driving cars, this is how the cars detect the lanes, by the way. So this is a great way to understand how they stay on lane. So, and we can test it out with a different image. Here we go, let's test it out with this one. Test image number 3. Change the name, and then just run the program. There you go. As you can see, everything is working fine, and yeah, that's all for this week, and I hope you learned something, and feel free to reach me if you have any questions. I will add my contact link below, and yeah, I hope you're staying safe, and yeah, continue learning and never stop. I'll see you in the next week's video. Until then, happy programming. See you. Bye.